Good morning, students. Today we are going to start the calculation of arithmetic mean. As you all know, arithmetic mean is one of the methods of calculating central tendency. It is what we commonly call an average. It is a single value which represents the entire data. Now let us discuss how we calculate arithmetic mean in different series. There are three types of series: individual series, discrete series and continuous series. In individual series, we calculate mean by using direct method and shortcut method. Direct method of calculating mean in individual series is sigma x upon n, the one that we commonly discuss. In the direct method, what we do is that we add all the observations, that is known as sigma x, and we divide that with n, that is the number of observation. A very common method we can understand by using this example in which 10 students are there. Their marks are given, like A student is getting 2 marks, B is getting 7 marks and so on. Now all we need to do is that we have to add the values of x, which comes to 50. The number of students, as we have already seen, is 10. So sigma x is 50 and n is 10. So 5 is the mean or arithmetic mean. This was the direct method. Now the same question if we do using shortcut method, the formula that we use in shortcut method is A is equal to sigma dx upon n, where A is assumed mean, sigma dx is deviation from the values of x, and n is the number of values. Out of all the values of x, we assume any one value to be the mean. This is known as assumed mean, which is represented by A. In order to calculate dx or deviation from x, we deduct assumed mean from individual values of x. Assumed mean in this case has been taken as 2. So we deduct 2 from the first value, that is 2, and we get 0. Same we do in case of 7. 7 minus 2 is 5. 10 minus 2 is 8, and so on. When we add the values of dx, we get sigma dx, which is equal to 30. Putting the values in the formula, now we get A, which is 2, plus dx, which is 30, and n, which is 10. So 2 plus 30 upon 10. Now by simplifying, we divide 30 by 10 and we get 3. So 2 plus 3 is equal to 5. The arithmetic mean is 5. As you can see that we used direct method and we used shortcut method, but the arithmetic mean that we got was the same value, that is 5. Now in case of discrete series, when we use the direct method, the formula is sigma fx upon sigma f. Sigma f is the total of frequencies. Now how do we calculate mean in discrete series using direct method? Number 1, in column x we put all the data of the marks received by the students. In column 2 we write the frequencies. In column 3 we calculate fx, that is frequency into individual values of x. The total of this column is sigma fx. We have used an example to elaborate it further. We write it in the form of a table or columns. So the first column represents x, all the values of x, that is marks received by students. In the second column come the frequencies, and in the last column fx. So As you can see, we have multiplied 5 into 4 in order to get fx, which is 20, 2 into 6, that is 12, 3 into 8, that is 24, and 4 into 6, that is 24 again. When we add up these values, we get 80. Now, putting the values in the formula, we get sigma fx, that is 80, and sigma f, that is 24. So, 80 divided by 24 is equal to 3.33. So, the arithmetic mean using direct method in the discrete series in this example is 3.33. Again, in the same example, if we use assume mean, the method is known as shortcut method. How do we calculate mean using shortcut method? First of all, we write all the values in the given data in the first column and denoted by x. In the second column, we write all the frequencies. Next, what we do, out of all the given values of x, we assumed any one value to be the mean and denote it by a. In this example, the assumed mean is 2. In the next column, that is the third column, we calculate the deviation of individual values from assumed mean and denote it by dx. Dx is equal to x minus a, that is assumed mean. In the last column, we multiply individual frequencies by dx, and the sum of this column is known as sigma f dx. Now, let us solve the question. As we know, the first column represents all the values of x, which in this case are 5, 2, 3 and 4. The frequencies are 4, 6, 8 and 6. The total of these frequencies is 24. The third column, as you know, the assumed mean is 2. So, all the values of x, we deduct assumed mean from those values and we get dx. So, we deduct 2 from 5 and get 3. Again, we deduct 2 from 2, we get 0. From 3, we deduct 2 and we get 1. And from 4, we deduct 2, we get 2. So, this is what we call dx or deviation from x. The next column f dx. What do we do here? We multiply the values of the second and the third column. Frequency is 4 and dx is 3. So, f dx is 12. Frequency is 6, dx is 0. So, f dx is 0. Frequency is 8, dx is 1. So, f dx is 8. And frequency is 6, dx is 2. So, f dx is 12. When we add the values of the last column, we get 32, which is sigma f dx. Now, we put these values in the formula. Formula is a plus sigma f dx upon sigma f. So, a is 2, sigma f dx is 32 and sigma f is 24. So, 2 plus 32 upon 24 is 3.33. As you can see that even when we have used the shortcut method, the value of mean remains the same as in case of direct method. Now, we will learn how to calculate mean in the continuous series. Continuous series, as you know, is the series that is having class interval. So, here the wages are given as 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Whereas, number of workers which will represent frequency is given as 8, 9, 12 and 11, and in the last category 50 to 60 it is 6. When we calculate arithmetic mean in this series, we are going to do it in the following manner. Here x is the wages, but we cannot identify one number for x. So what we need to do is we need to find out mid value of each group. Mid value is L1 plus L2 divided by 2, where L1 is the lower limit and L2 is the upper limit. In case of the first class, the lower limit is 10 and upper limit is 20. So 10 plus 20 divided by 2 is 30 divided by 2, that is 15. In the second class, it is 20 plus 30 divided by 2, that is 50 divided by 2 equal to 25, and so on. So first thing that we are going to do is we are going to find out the mid values of these classes. Now once we found out the mid values, they will represent x for us in this case, and the next step is we multiply the individual frequencies with the values of x, that is mid values. So in this case, the first frequency is 8 and the first mid value is 15. So 8 into 15 is 120, that is fx. 9 into 25 is 225. 12 into 35 is 420. 11 into 45 is 495, and 6 into 55 is 330. So the total of the frequencies is 46 and the total of fx is sigma fx, which is 1590. Now we use the following formula. This is when we are using the direct method in case of continuous series. The formula is going to be sigma fx upon sigma f. As I told you, the formula will be the same in case of discrete series and continuous series, with the only difference that in this case x represents mid values. In some cases it is also written sigma fm, so it is also correct if you represent mid values by m, but in this case we have taken sigma fx. Now putting the values in the formula, sigma fx upon sigma f, sigma fx is 1590 and sigma f is 46. So we get the answer. The mean using direct method in continuous series is 34.56. The same example, if we use shortcut method, remember shortcut method represents that in this method we are going to use assumed mean. So mainly the steps that we have done so far will remain the same, with the difference that in this case out of the mid values we are going to assume a mean. So the first step is we are going to calculate mid values as we did in the case of direct method. Amongst the mid values we will select a mean which will be known as assumed mean. In this example, the assumed mean is 15. Now the next step is when we calculate dx, deviation from x. So from every value of x we deduct assumed mean, which is 15 in this case. So the first value, mid value is 15. From 15 we minus 15 we get 0. Next mid value is 25. From this we minus 15 we get 10, and so on. In the next column we calculate f dx, which is simple, frequency into dx. Frequency is given as 8, whereas dx is given as 0. So the first row f dx is 0. Then next 9 into 10, so it is 90, and so on. So we calculate f dx, and the total of this column known as sigma f dx is equal to 900. Now we are going to use the formula a plus sigma f dx upon sigma f. Remember, this is the same formula we were using for discrete series also. So now we are going to put the values here. A is 15 plus sigma f dx is 900 and sigma f is 46. So 15 plus 900 upon 46 is 34.56. The value of mean calculated is the same as it was in case of direct method. In continuous series, we can also use step deviation method. Step deviation method is just one step away from the shortcut method, in the sense that the first few steps will be the same. We will calculate mid value, from mid value we will calculate assumed mean, and we are going to find out deviation from assumed mean. Only the difference is that in this case we are going to divide dx by c, which is the common factor. As you can see that dx is 0, 10, 20, 30 and 40. So there is a gap of 10 in all of them, or we can say the common factor in all of them is 10. So when we divide dx by a common factor, which in this example is 10, we get dx dash. Now in this question, the only difference is going to be, we are going to multiply the frequency with dx dash. So frequency, as you can see, is 8 and dx dash is 0. The answer is 0. Next frequency is 9. We multiply it by dx dash, which is 1, and we get 9, and so on. The total of this column is sigma f dx dash, a plus sigma f dx dash divided by sigma f into c. So a is 15, sigma f dx dash is 90, sigma f is 46, and common factor or c or constant is 10. The answer is 34.56. Even though we have used 3 different methods for calculating mean in case of continuous series, we can see that the answer is the same. Here we have given the formulas at a glance for all the series and all the methods. That's all for today, children. Have a nice day.